All right, today we're going to be working with solubility curves in Concept C. I would go ahead and get your reference table so you can be looking at Table G with us. All right, the amount of solute that will dissolve in a given amount of a solvent at a given temperature and pressure is called solubility, and that's what we're going to be working with today. Now, some substances may be mixed in any proportion. Two things that are miscible refers to either two gases or two liquids that can form a solution in any proportion, such as water and vinegar over on the left. However, you can see that oil and vinegar do not mix. Most substances that are not soluble or miscible, there's a limit to how much solute will dissolve. This extra solute will drop to the bottom, which is called a precipitate. So we have three different types of solutions. The first one is a saturated solution. This is when it holds as many dissolved particles as it can theoretically possibly hold. This is the maximum amount of solute that will dissolve in that given amount of solvent. No more solute will dissolve. If we try and add any more, it will simply settle to the bottom as a solid or as a precipitate. Now the other type is an unsaturated solution. This has not yet reached its saturation point. We can add more solute in. If we do add more solute, we can dissolve it. And again, this is when it's underneath the saturation point. Now, supersaturated, this is a rare situation. It's holding more solute than is actually theoretically possible. This usually requires an initial increase in temperature or pressure. However, this is, because it's a rare situation, it's also very unstable, and a slight disturbance will cause the solute to precipitate out and form a separate solid. You can see some examples here of how we have an unsaturated solution, but once we have saturated, we add more of the salt in, it's just going to settle at the bottom as a separate solid. All right, so Table G, this involves our solubility curves. This shows how the solubility of a salt substance, the amount, changes with temperature. So we're solely focusing on temperature. We're going to hold pressure constant and leave that out of this relationship. So using our solubility curves, we can tell how much solute in 100 grams of water can hold at any given temperature. Each line of this table represents a saturated solution of a solvent at different temperatures. So again, I can figure out, if with my 100 grams of water, how much solute I can saturate that solution with at any specific temperature from 0 to 100. So if I was asked what's the solubility of potassium nitrate in 100 grams of water at 50 degrees Celsius, I would start at 50 degrees Celsius. I would go up until I hit the line for that compound and then go across to my y-axis. So this shows me that 84 grams of solute will dissolve and saturate in 100 grams of water. All right, so now this is one where we're asked about at what temperature will the solubility of potassium nitrate be 50 grams per 100 grams of water. So what is my temperature that this would be saturated at? So I would go ahead, I would start at my y-axis, move across to the line, and then go down to my x-axis to find out the temperature, and I would get about 32 degrees Celsius. At what temperature will it be 100 grams per 100 grams of water? So again, I would start over on the left, go across until I hit the line, and then go down so I can see the temperature. And I would get about 57 degrees Celsius. So pretty straightforward. I'm just starting with my grams of solute in order to figure out the temperature of which that solution would be saturated. Now, how much ammonium chloride must be added to 100 grams of water at 70 degrees Celsius to saturate it? Here I'm given the temperature. I'm asked to find the amount of solute. So I start on the bottom, on the x-axis, I go up until I hit the line, and then I go over to the y-axis to find my amount of grams. Now, one thing I do want to point out at this point is that this is in 100 grams of water. If you look over at our y-axis, it says solute per 100 grams of water. So if I change the amount of water, I'm going to affect this amount that I've calculated, so keep that in mind. So what happens when this water is different from 100 grams? So you could use a proportion to help you determine the grams of solute when you change the amount of water. But the most common ones you're going to see is when we have 50 grams of water, 200 grams of water, sometimes 300 grams of water. If the solute is dissolved in 50 grams of water, that's half as much solvent as usual. So we're going to only need half as much solute. So you're simply just going to cut the amount in half. If I double the amount of water, I also double the amount of solute. We'll be practicing a lot tomorrow in class. So for example, how much HCl can 50 grams of water at 20 degrees Celsius hold. So I'm going to use the same process as before, start at 20 degrees Celsius, go up until I hit the line, and then go over, and I see that I get 70 grams per 100 grams of water. Okay, now because I cut the water in half to 50 grams, that means then that I also have to cut the amount of solute. So if I have 72 grams in for 100 grams of water, I only need 36 grams in 50 grams of water. So half the amount of water, half the amount of solute. Okay, you could also set a proportion here that for every 72 grams of HCl and 100 grams of water would be equal to our unknown in 50 grams of water. So you could also do that instead. All right, another type of question is called the degree of saturation or degree of solubility. We want to know what kind of solution forms under certain temperature conditions and grams of solute. Now, what you're going to see is that if our criteria lands on the line, that means we have a saturated solution. If our temperature and grams of solute land us above that compound's line, we say that it's supersaturated, and below is unsaturated. So you can have that right there. All right, so what type of solution is 100 grams of water, which holds 40 grams of KClO3 at 30 degrees Celsius? So I want to see where these 2 points are going to meet on the graph. So I have 40 grams of KClO3 at 30 degrees Celsius. I'm going to see where they meet. Okay, and then I'm going to compare that to the line for KClO3. KClO3 is this line right here, where my arrow is. Okay, where the red dot is. Because my point, the purple original dot, is above the line, that means that I have a supersaturated solution. All right, one other thing I want to talk about is just determining what is most soluble at 70 degrees Celsius, at 10 degrees Celsius. We can find at 70 degrees Celsius, here are my 3 points. Most soluble means the most amount of solute, so that would be my NH4Cl. If I'm looking at 10 degrees Celsius, okay, I move all my dots over to the 10 degrees Celsius. I can now see that NH3 is the most soluble. One thing I want to point out, and I'll mention this in class, there's 3 lines that are going down as temperature increases. Remember that as temperature increases, gases solubility decreases. So HCl, NH3, SO2, those are all gases, and that's why their lines are going down. One last little thing. What do we do when we have an unsaturated solution? How can we saturate it? We can either do this by simply adding more solute, or we could actually lower the temperature. That can also cause the solution to become saturated. A supersaturated solution can be saturated by 2 ways as well. We can cause the excess to precipitate, remember it's unstable, or we could raise the temperature and move our supersaturated solution to a saturated solution. Okay, well that is it. So we will continue on with this tomorrow, work a lot with our solubility curves in Table G.